Hello everyone, welcome back to my channel. Today we're going to talk about networking, Wireshark, and So let's start. So the objective is to master TCP/IP, TCP/IP stack architecture protocol, analyze network traffic with Wireshark professionally, understand critical power protocols, like detect anomalies, suspicious patterns, perform network reconnaissance. The Nmap. So this is actually an important topic, and networking is very important if you want to learn hacking or penetration testing. So also I recommend that you go through my CCNA course that I uploaded few weeks back. Okay, you go through it. Okay, because network is a very important topic. At least, the key topics you have to understand how it works. At least the first few episodes of my CCNA course, you should at least watch that. At least the first, first few episodes, just so you can see the protocols and the benefits of each protocol. So this is TCP/IP architecture, the stack. Okay, TCP/IP architecture, we have 4 layers. Okay, but this one is not showing you the full thing. But we have layer 1, layer 2, layer 3, and layer 4. Okay, so let's go through layer 4, which is HTTP, HTTPS, DNS, RDP. All this are application layer. This is where the application actually is. Okay, this is layer 3, the transport layer. This is the TCP UDP. TCP. The difference between TCP and UDP is actually TCP is connection oriented. That means it has and UDP is connectionless. Okay, mainly UDP is used for voice, for voice over IP communication, video, this stuff like this, and TCP is used where you need a reliable connection, where it has it acknowledges that it receives a packet, the other side can acknowledge, and also it has sync and acknowledgement feature here. UDP doesn't have that. It just sends the packet. That's it. It doesn't care if the end user received the packet or not. It just sends it. That's it. So layer 2 is basically the cable. Okay, the IP, the IPv4, IPv6, ping, ARP. This is the line that we use, okay, to connect each network, like IPv6. This is the ARP, ping. Okay, so this is the internet. Okay, this layer 1 is actually the MAC address. Let me go ahead and put it or no need, let's just put this one up a little bit. I'll put it higher. No, put the content higher here, and this is layer 1. Layer 1 is actually the link. Okay, the MAC address, the Ethernet, the Wi-Fi. This is where the cables is connected. Okay, where the MAC address, Ethernet, and Wi-Fi. Yeah, and this is layer 2. This is the IP layer, ICMP layer, ARP layer. This is in OSI layer. It's actually the layer 3. Okay, and this is actually a data link layer, and so the layer 3 is where the transport layer, where the data is transmitted from one point to another device. Right, this is the application layer. This is what you see when you receive the packet, like the website and all this stuff. This is the application layer. Okay, And TCP/IP, like we have two actually architectures, but the latest is TCP/IP. We can compare it here versus OSI layer, OSI model. Let's go to the image and see, so we can understand what exactly is the difference between them. Open image in a new tab. The quality of the image is actually not good, so we cannot see it. Yeah, this one is better, so we can just increase the size and we can see what it is actually. No, because this is only showing the. No, yeah, it's okay. Yeah, so basically, okay, so we can understand what exactly it is. So this is the OSI layer. OSI layer has 7 layers. It has the physical layer, data link layer, network, transport, session, and presentation and application layer. Okay, the physical layer is where the cable, the media, like the main connection between two PCs or two network devices, like any line, that's the physical layer, hence the physical name, the name physical, right? Data link layer is the MAC address, like for example, yeah, the MAC address, LLC physical address. Okay, this is how you identify the devices, right? The key identification. This is the data link layer. Okay, these two actually are combined into one layer in the TCP/IP layer. It's called the link layer here. If you go to this one, the link layer, this is TCP/IP. It combines both into one: MAC address, Ethernet, and Wi-Fi. Okay, and the network layer, this is where the routers or the layer 3 devices, like IP, where you assign the IP, right? IP communication, the packet, yeah, where you put the packet. This is the network layer. Okay, here also it's same actually. Network layer is mentioned there as an internet layer. In TCP/IP, they just renamed it internet layer. The IP ping ARP, yeah. So yeah, and transport layer, this end-to-end connection and reliability segments. So this is TCP UDP, and yeah, there also. So this 3: session layer, presentation layer, and application layer are combined into one actually. They call it an application layer in TCP/IP stack. Okay, you just need to understand this diagram. And TCP/IP architecture, we have like the IP layer. The IP layer. IPv4 fundamental. This is the IP address. IP address is like 32 bits, 4.3 billion addresses. Subnet mask determines the network versus host portion, CIDR notation, network prefix length. So I'm not going to go in depth on each topic, on each point here, but what we need to understand, IP address is like this one. See, like whenever you go to any PC that's connected, in order for it to get any access, network access, internal, whether it's private network or internet access, it has to have an IP, right? You can go here and check like this details. It has to have an IP, right? This is the IP address 192.168.159, right? This is the IP of my PC. Okay, and this IP I'm getting it from the DHCP server. Okay, the DHCP server is any device that distributes IP addresses to devices. Okay, to other devices. So, for example, right now my DHCP server is my modem. Okay, this is the DHCP server. This is the modem, the IP of the modem, and I'm just getting IPs from this modem. Okay, and it's giving me IP based on the subnet mask that I set there. Like there are different ranges of IPs you can set. Okay, like is the subnet mask 255.255.255.0. That means the first one, the second one, and the third one here, they're not going to change. Only the last one can change, right? See, this is yeah, the last one can change. Like now, if you go to other PC now, maybe I will get the same the same first 192.168.1 dot something else, some other number here, maybe 60, maybe 61, whatever. Only the last will change because this is the subnet mask it's asking. So in order to understand IP layer better, okay, so we have to actually go to the I don't want to go through each point again because I went through it in my CCNA course. So you have to go through this video. Let me show you. Let me show you which video we need to see in order to understand it properly. This one. One second. Yeah. So I have a playlist actually. This playlist is in the yeah, this is the CCNA playlist. Okay, so look, I will advise you to go through this one. Okay, if you are very new to networking, you have to at least know this one and this one. Okay, and go through subnetting. Subnetting is important because basically you'll be dealing with the IP addresses when you hack, right? Whenever you hack, you do any ethical hacking or penetration testing, IP address information is important. Go through this one. Others you can skip or go through it. It's not really that much. You can skip this one, no problem. This one, this I think you should know. This one I think you should know. Not as but you can skip it for now, no problem. DHCP, Wi-Fi, QoS, IPv6. You can go through this as well. Go through this one. Okay, you can skip this one. Skip this one. Skip this one. Yeah, you can skip this one. Okay, like go through this sessions. Okay, this one, 1, 2, 3. So you can get a good understanding, initial understanding, and go through also this one, Wi-Fi, TCP relay. I see this one is important for security, and you can it's preferred to go through all, but if you have to choose, you go through this 3-1. Okay, so subnetting, what you need to understand is I have notes here about subnetting. So let me summarize it for you. I'm not going to talk about all of this, but these are the things that you need to understand. Like this is the CIDR rotation. Okay, classless class interdomain. Okay, this is CIDR. This /25 means this is the mask address. Okay, /26 means this is the MAC address. This and you just have to memorize this table. Okay, and then it's just a matter of knowing the block size, like 1 to and then you can do the subnetting. But again, I have went through this already in my previous session, so I don't want to go through it again. And yeah, so TCP versus UDP comparison. We just need to go to we have two types. Like this is you need to understand the difference. TCP connection, we said it's reliable delivery, okay, and in order sequence. Okay, the sequence is ordered. Error checking, it's slower but trusted. Okay, port 22 SSH, port HTTP, HTTPS, all these are actually TCP. Handshake is SYN, ACK, FIN. UDP is best effort delivery, no ordering guarantees, minimal overhead, fast use for streams, ports 53, 67, no handshake. So these are the things that we need to understand. Yeah, the difference. The main difference is that this is reliable, and it has an order sequence, TCP, and this protocol are actually TCP. So SSH, HTTPS, HTTP are TCP. Well, UDP is DNS, and so the handshake. Yeah, this is the TCP handshake connection. Okay, so there is a three-way handshake for TCP handshake and connection. So first, the client sends the server a SYN packet, synchronization request. Okay, and the server sends the client a SYN ACK, acknowledgement plus server request. That means I have received your synchronization request. Okay, so then the client sends the server acknowledgement. Okay, I understand. Okay, then connection established. So this is how any TCP connection is established. Okay, three-way handshake. SYN ACK, acknowledgement. Okay. So yeah, I will repeat this again. The client sends the server a synchronization request. Okay, then the server sends the client a SYN ACK acknowledgement that it receives the synchronization request plus a server sequence. Okay, and then the client sends the server acknowledgement of the server sequence. Then connection established. That's it. To close the connection, we'll use client sends the server FIN, this end connection. Server sends the client acknowledgement of the end. Server sends the client FIN, server ending. Client sends the server acknowledgement, final acknowledgement. Okay, let me show you in how it is in the diagram so we can. Open image into new tab. Yeah, so as you can see now, this is the client, right? Active open, so it sends a synchronization sequence A. Okay, and then once the sync is received by the server, it sends a sync plus acknowledgement to the client. Then the client also at the same time it sends a sequence. Okay, don't forget the sequence. Okay, then it sends an acknowledgement for the sequence, server sequence. Okay, that's the three-way handshake. So port states and critical ports. For Nmap, yeah, we have three states. When Nmap is a tool that's used to check scan the IP. Okay, and also it's used to check the services of check which ports are open on those services. It's used to scan like which hosts are live, which are down, and yeah. So we need to understand that open means service actively listening, response with SYN ACK. Okay, and closed means no service, but port responds to with RS set. Okay, and filtered means firewall blocks, no response. Critical ports that we need to know is 2 to 22. 22 means SSH. We have to memorize this actually. 80 means HTTP, which is web, insecure web, and HTTPS is 443. 53 is DNS port. 445 is SMB. 3306 is MySQL. 3389 is RDP, and SMTP is 25. Okay, so let me show you what Yeah, so let's say this is the critical port. Like, let's go through, we will go through it one by one, those important ports. So we have DNS, and again we have talked about DNS, okay, in my previous in depth in my course here. Okay, I've went through the detailed process of how it works, and I also suggest you go through this video. 1 second. Here, not this one, not Cisco. It's on the Windows server. Here I have I've talked about DNS and DHCP process in details, how it works and how it is, and you have to go through this one as well. So it's a good video, and you can learn also about Active Directory, and this which we will go through in the coming sessions. Yeah, it's very important. So DNS is what you need to understand. It uses port 53. Okay, and domain to IP. It's used to translate the name to IP. Okay, so attacker returns false IP address. Yeah. So let me show you an example. Let's say that I want to go to Google. Now, if I type this, okay, it's using DNS translating it to IP. Okay, Google has different IP, right? So DNS is responsible for changing the name to IP. Let's go to ping google.com. So as you can see now, this is the IP of google.com. DNS just changes the domain name to translate it to IP. Okay, DNS spoofing. Attacker can return a false IP address. Attacker can spoof and return this false IP address. Zone transfer, unauthorized copy of DNS record. Like DNS styling, hiding data in DNS queries. Okay, like this port 53, because this is a port that's always enabled by the firewall. Okay, it can be exploited by attackers. Like, they can use it to hide data, pass some malicious data and through it. You know, use DNS tunneling. It hides on DNS queries. Okay. So the critical protocol that's for other is like HTTP and HTTPS. HTTP is plain text, credentials visible in packets. This is not secure, by the way. HTTP, everything's like plain text. It doesn't use any encryption. But if you use HTTPS 443, it's TLS encrypted secure communication. Okay, get request data visible in the URL. Okay, post sends data in body but still visible in HTTP. Cookie sessions authentication. So this get is like when you, let's visit any website like Vol Web. Yeah, test PHP, yeah, this one. So I opened this just so to show you what's HTTP. This is actually a vulnerable website, intentionally, it was made intentionally vulnerable by Akinetics so that we can practice attacks to it. This is, you see this one? It's telling you no secure because it's not using actually HTTP. It's using it's not using HTTPS. It's using HTTP. We can confirm this by going to Network tab and yeah, you can see here. Okay, you can go to the Network tab here and check. Not here. Go here. As you can see, the request URL is http test vulnerable hub, right? It's using HTTP, it's not secure. Request method is get. Get means whenever fetching. Get means fetching. Request that's visible in the URL. Okay, that means when you fetch something, it's using guest request method. Okay, when you post something like let me show you. let me show you where sign up here. Okay, this one, if I put something here, it's going to be post. This is a login, okay, because I'm trying to put send to the server, right? So let's go here. Here, yeah, this one. You can see here user info. This one is saying post. The request method is post because I'm trying to enter to the server. This one sends data, okay, to the body. Yeah, this is post. Cookies, session token, authentication are cookies are this. 1 second, let me show you what cookies are. Cookies are actually, you can see it here. Okay, cookies are stored here. Usually it's used for authentication, and but let's log in and see. Let me show you how I can. The default password is test. The username is test also. Okay, I just logged in. Okay, now you can go through the cookie. Now you see. No, this is actually it's not supposed to be here. 1 second. It's not supposed to be here. Let's go test here. So I just logged in. Actually, when you log in, it takes you somewhere else, I think. But anyhow, let's just check the cookie here. So this is what we call by cookie. This is what a cookie is. Okay, a cookie contains. Let's see here. It has like path expiry, and it has like this stuff. So this is what we call by cookies for authentication and tracking for sessions. Okay, let's say I logged in now. It's going to save a cookie. The server is going to give me a cookie. Server, yeah. So SMB. And also one more thing, like if we had used Wireshark here, right now, let's see if we have it here. Okay, if you have, let me show you why we don't use HTTP. We prefer HTTPS instead of HTTP. So let me go here to Ethernet. Okay, refresh this page. Okay, let's just type test, and the password is test also. Done. So we have already tested. So let's go ahead and check the Wireshark. Okay, don't worry about Wireshark, we'll go through it in this session. Just give me, let's just check the HTTP traffic here. Yeah, as you can see here, now if I go to follow TCP stream, it's going to show me all the results of this traffic, but also the password here. You see this one? I was able to get test and pass, the username and password, without any issues, because it's visible, it's passing, it's going through the network like without any encryption. Okay, that's why we don't prefer to use HTTP. Always look at websites that has what do you call it, that's using HTTPS like this. You see, it's secure. And SMB, window file sharing. Okay, port 445, window file printer sharing. Yeah, SMB is used for sharing files. Okay, it's a protocol used for sharing files. Okay, and window file printer sharing, it's used 445. LLTM authentication, window credential authentication, IPS mechanism exploitable, infamous. Yeah, this is vulnerability eternal. It's a famous vulnerability actually, eternal blue, that was created. Discover accessible shares. You can which you can check also, yeah, which shares are accessible. Okay, just so we know that SMB, we have two versions of SMB actually, SMB version 1 and version 2. Version 1 is actually disabled in most PCs, but version 2 is enabled. And you can see SMB here actually, this is SMB. Supports file sharing in computers, actually disabled also in most PCs because this is the modern PCs, because it's actually not a secure protocol. Okay, and so but in legacy PCs or Windows you can find it enabled. It's considered actually a vulnerability. This is SSH and RDP. Okay, SSH is used to securely access any network device, like secure shell. It opens a secure shell because it pass encrypted. It allows encrypted remote login. Okay, so it has key exchange, DH, ECDA, encryption, AES 128, RDP. RDP is the same remote desktop protocol. So these are actually common brute force attack. This is remote desktop connection. Okay, let's say right now I want to access another PC from my own PC. Here, I can just use this one, right? And I will be able to access if it is on the same network, of course. And SSH is usually used for managing network devices. Like an admin can use SSH to configure an access point or a switch or router or firewall. Like it allows you encrypted remote login from remotely, allow access remotely. Okay, now we'll talk about Wireshark packet analyzer overview. Wireshark is a real-time packet capture analysis tool. Shows network traffic at application layer detail. Powerful filtering and dissection capabilities. Exports packet, extract files, reconstruct session used for troubleshoot forensic security analysis. Okay, Wireshark is the one second. So basically we have seen what Wireshark. This is Wireshark. Okay, this is what we use to check the so let's go ahead. We have 3 pane architecture. Okay, we have the packet list pane, the top, summary of all captured packets. Let's open it side by side so we can see. Okay, like columns, number, time, source, destination, length, and information. We're talking about this one. Number, time, source, destination, protocol, and length. And packet detail pane in the middle. Expanded view selected packet. Show layer frame. Yeah, this one is what they're talking about. So this will show you all the layers. Remember we said that there are let's go through the previous packet and see this one. So this is what they mean actually. These are all the layers. This is the frame. Frame means this is the second layer actually. The first layer is bit. Ethernet is where you'll find the frame, Ethernet, IP, TCP application. Okay, all layers we have it here. We have the frame here, and we have the Ethernet. We have the IP, which is the Internet Protocol. Here you will find the IP address here, source address. You see this one, and we have the TCP, which is where you can find the TCP UDP stuff here, and we have the application and packet byte pane bottom at the bottom. and this is the packet byte. This one. This will display the packet bytes. And let's go ahead and fix this one as well. Wireshark packet. So TCP port 80 capture HTTP traffic only. Okay. Host this one capture traffic from specific IP. Net capture subnet IP. TCP port SSH show login request. So I'm going to go through this labs. Actually, we are going to go through it one by one. Okay. Because so we can understand it properly. Okay, we're going to start with this one. We're going to start with the first lab here, and I'm going to open Wireshark here. I'm going to type TCP port 80. Okay, what this means is like it's going to list for me all the HTTP protocol. 80 is HTTP protocol, right? It's the same thing as saying HTTP here. Same thing. Like it's going to list all the traffic's only HTTP. Okay, and then I'm going to say the host. This is my my PC IP. Okay, I'm going to say IP address. Remember this commands actually. IP adder equals to 192.168.1.59. This is my IP address. Okay, it's going to show me all the packets that contains this IP, either in destination or source. Okay, and IP adder, and let's see, we have here http.request.uri contains login. So what we are saying here is that I just want to see the login request. That's it. It's a very important command also. http.request URI contains login. So it lists for me the login, the one that we use for page to test the HTTP, and the other. And we have here also capturing DNS queries and HTTP traffic. We have here DNS queries. You can just type DNS. It's going to show you all the DNS queries. The Wireshark here, DNS, all the DNS queries, and you can also do flags.response equals to 1. Yeah, this is with the DNS response queries with DNS, right? Answers. If you type DNS, it's not going to list the response. It is. Type. Yeah. And let's say we want to see HTTP dot request dot method equals to get. Let's put it capital. Yeah, it's going to give me all the HTTP request that comes with get method. Okay, you can change this one. Request method, you can put it post. As discussed before, we said that post is when you like log in or put any data inside the body to send it to the server. Okay. Well, get is you are fetching from the server, displaying it on your page. Like that's the difference. Like when I log in, I'm going to use post, right? When I want to put any data, enter any data, send it to the server, it's post. When I want to retrieve data from the server, it's get request method. I'm going to use get request method. So the main thing that the command that we need to use is this one. You need to remember is this one. Right click, follow, TCP stream. This one will give you the end result, the final result. Okay, you have to keep that in mind. And yeah, you can just click here, TCP stream. It's going to give you the result. And we have here TLS handshake dot type equals to 1. This is going to list the client hello packet. This is going to say list the client hello packet. This is going to say the server hello packet. Okay, TLS is a protocol that's used with HTTPS to secure the encryption. Yeah, we've got to go through it each one so we can understand Wireshark properly and then move on. Yeah, let's just fix this one first, and yeah, fix this one. Okay, now we can go ahead and practice it. So let's go ahead here, finish this one. Let's go to this lab. So this is for file extraction. Okay, we're supposed to extract file or credential from traffic. Okay. So in order to extract file, there is a command we use here. Not a command actually. We just want to extract some file. You just go to file, extract object here. But remove this one for a moment. And file, extract object. It will give you an option like. It will give you an option here. Edit extract object, either HTTP you will use or SMP or TFTP here, and it will download for you the object. Okay, file export object, SMP, like extract shared files. Yeah, and yeah, protocol analysis, like we can see here. So basic auth is base 64 encoded in HTTP header, easily reversible, and visible in authorization header, bearer token, can be replayed session cookies if captured. So you can check the authorization using this command. If you go here, http dot authorization header here we have SMB and SSH analysis, capture advanced protocols, We have let's see what time is it first before we move on to the next session. Yeah, okay. We have SMB protocol and LTM. Oh yeah, this if you want to check the LTM, the SMB protocol. Again, I recommend you you download Wireshark. Okay, you can download it from here. Okay, it's very easy to download Wireshark. Just go to Wireshark, download, and you can download it from here, from the website. It's free. You can choose the Windows installer. If you're using Windows 7, Windows, you can just download it from here. It's going to download for you. See, and you can install it. Once installed, it's very simple. All you have to do is like quit. So let's go ahead and do like Wireshark here. Start, and once you start the Wireshark, you can choose which network, which interface you want to capture the traffic from. Like I chose this one because I'm connected to the Ethernet one, right? If you're connected to Wi-Fi, you can use like a different adapter like Wi-Fi here, based on which traffic you want to actually capture. Okay, it's up to you. Okay, then you click it, it'll automatically start capturing all the traffic. You want to stop the capture traffic, there is an option to stop capturing here, and yeah, there's an option to start capturing here, and yeah, you can start from here. And as discussed, once this, in order to export, you have to stop capturing. Actually, once you stop, you can export it from here. The exported data, you can export it here from here. Okay, but while it's running, it's not you want to save, continue without saving. Okay, while it's running, it's yeah, you can export from here. Okay, and basically that's it for now, and we are going to go in depth on this actually later on when we start Blue Team. We'll go through it in depth. We'll do actually actual practices, labs. We're going to use traffic analysis here. Traffic analysis. No, traffic analysis malware. There is a website that is used, the malware traffic analysis. This website, it's actually useful for testing, practicing. It's going to give you infected traffic. Okay, you're just supposed to identify, to ask you questions. You're supposed to answer the question based on your findings. Like, yeah, but you have to be careful because this is actually risky. You have to make sure that you do this on a VMware or somewhere else, yeah, not in your PC. Yeah, so basically that's it. But we'll do this on when we start Blue Team. Right now, you just need to focus on understanding the key ideas, the main points, just so you can navigate through. You can understand what I'm doing when I'm explaining to you. So SMB, you just have to type the name of the protocol you're going to get. You get it. This is one way of finding it, or you can just do an LTM SMB. Yeah, sometimes you just want to type the name of the protocol. It's that simple. Okay, common attack ports. You can type here TCP destination port N. This is 22, 3389, 445. Yeah, so let's put it 3 here. Yeah, so it's not going to, yeah. So if you remember, these are the protocol for SSH. This is for RDP, I think. This is for SMB 3389. Yeah, so what I did is to see if there is any traffic on those ports. Okay, so Nmap is network scanning. Before going to Nmap, actually I think there is one more topic on Wireshark. Yeah, advanced here. Yeah. Yes, just one more traffic. So I'm just going to go through it before moving on to this advanced statistics analysis. In Wireshark, we have a tool. We have a way we can use like statistics here. Okay, so we go to statistics. Okay, and you go to endpoints. Here it's going to show you all IPs involved, like all IPs that are generating these traffics. You can see here IPv4, all the IP addresses with the bytes and everything. Okay, and yeah, endpoints. Also, if you go to statistics and you go to conversation, here this is the traffic flow between hosts. Okay. It's a traffic flow between hosts. Traffic flow between hosts. Yeah, so you can say here, for example, address A is going to, when this IP is communicating with this IP, this is the packet that's generated, this is the byte. Yeah, it tells you which IP communicated with what IP. This is useful for SOC analysts, so they can identify where if there is any attack originating from where, or if there is any if there is an attacker trying to exfiltrate, take data outside of the organization or company. You can see their IP here. Okay, and there is one more here, Wireshark statistics protocol hierarchy here. Protocol hierarchy and protocol breakdown. This listing all the protocols that are being used. Like here we have DHCP version 6 and stuff, and net bias stuff. Yep. And we have IO graph. IO graph, you can find it on the, I think it's on the same IO graph here. This is the graph of all the input output. Expert info. Wireshark identifies issues. Let's go to statistics, go to expert info. It's not here. Yes. Yeah, expert information here. So this export information, this is what Wireshark detected, like notes, DNS query, transmission errors, and yeah, just keep this in mind. This is actually advanced for now, for you for now. So just go ahead and go through next topic, which is Nmap. Nmap is a very important tool. Okay, it's used for network scanning. Okay, and it's also used to identify the services that are installed inside the server or any PC that are open, and what kind of service there are, and what's the operating system. This is always used to identify the operating system of this IP. What operating system is used? A is used like to scan the known port. SN is just used to scan the network, just to check if it is which IPs are live, on or out, off. It doesn't give you the ports, which open ports are there, which service, all that. It doesn't give you this information. If you use SN, initially we use SN just to see which IPs, which PCs inside the subnet are live, are working and up. Okay, and then we can proceed to see the open ports. There is to check the open ports, you can use -p-, and you can scan the top 100 ports, common ports, and then and then you can check the service operating system if you need and stuff like that. So for this, I think it's better if we just do it. I'm going to open VMware so we can see in practice what exactly it is doing. I'm going to open Kali Linux, and I'm going to open, I prefer to open the Windows Server. I guess let's open the Windows 10, no problem. Let's open Windows 10 just for understanding exactly what it's doing. I'm going to run here Kali here. James. Yeah, I'm going to try these commands. Okay, but first, best thing I can do right now, let's say I want to see what's the IP of this, but first let's see if they are on the same network, because this is not actually on the same network. Let me use VMnet2 to put it inside the same network, and Windows 10, let's see if it is yeah, it's using VMnet2 as well. So let's go ahead and try it out. So I want to know what's the IP of the I think this was configured DHCP. That's why it's not going to get IP. It's supposed to get DHCP from the Windows server. But yeah, so let's just turn on the Windows server. It's okay. It's okay. Let's just turn on the Windows server. Okay, so we can get IP from both the Windows server for both the Kali Linux and Windows, because I've configured the DHCP on the Windows server. Let's see if we got an IP first. ifconfig. Maybe we just get an IP. No, we didn't actually. Let's wait to the Windows server. Let me pause it so that it doesn't take. Yeah, so I got the IP here. Okay. And let's see if the Windows got the IP or not. CMD. IP config. Yeah, I got the IP as well here. This 21 and it's 22. So first thing I'm going to do, I'm going to scan network just to check how many PCs are actually online. I'm going to use nmap -sn. I'm going to use the network. This is my network because I'm getting this IP, right? So I'm going to scan now. This is a command to use. You just type nmap sn and it will tell you how many IPs are on. 3 hosts are up, but it didn't actually display the IP address here. In order to make it display, we have to use the command on hosts.txt. So it will store it inside the host. It will scan and put it inside the host file, the IP address. We can open the no, actually it's displayed. Actually, we don't need to put it in the host, but yeah, we know that now we have one. This is the HTTP server's IP address, and this is the IP address of the Windows 10, and this is the server, I think. So now that we know this one, so let's confirm first the 21. Yeah, 21 is the server. So now we know that 21 is the server, so let's go ahead and check. Let's do a scan. Let's scan let's do an nmap scan. And nmap p target.com. But before doing that, I want to actually do this one, the normal scan. Okay, -sv scan 10.0.0.21. Let's do this one so we can see what it will output actually. Yeah, it just gave me the services: Microsoft Windows Service, Mac, yeah, service info, OS, Windows, perform, please report any incorrect. So it gave me the service information here. Okay, I can try like O to see the operating system, specifically operating system /-o, and it will work this way. So our goal is actually to find the open port. Once we have identified that what are the live PCs, we're supposed to find the open ports. Okay, and service version, like we can find service version also, so that we can find vulnerabilities, to identify the vulnerabilities, and then we can do OS fingerprinting, determine the target operating system, and also we have scripts, NSC script for deeper analysis, script made from Nmap. Okay, you can use, it's ready made, like you can check. Let's go ahead and do this command first. Yeah, see, the O actually just gave us the Windows here. Yeah, so it gave us the operating system and which one has the highest probability. This one. It tells us this Microsoft. It's Microsoft Windows 10. Okay, it was able to identify that from the scan. So let's clear this first. Nmap sv script equals to vol target.com. We're not going to use target.com, actually we're just going to use 10.0.0.0.21. So this is a vulnerability scan. Okay, this might take time. which is the issue actually, because my goal is it has to be less than 30 minutes. We have to finish the pending because I don't want to put more than. And this -p, you can try it out by yourself. Like, it will show you the open ports. Okay, network anomaly detection, identifying suspicious pattern like port scanning, multiple SYN and RST no response, patterns, and brute force many failed connections to SSH or RDP, DNS tunneling, unusual DNS query volume or size, data exfiltration, large outbound traffic to unknown IPs, lateral movement, internal traffic to multiple hosts. So basically what this means is that let's see first if it's display. Yeah, this is done. So it's going to tell you that host is up 999 TCP. This is it. It didn't give us much, but let's see this command, the last command. I can use this command to scan all 6,000, all the ports, all the available ports, and you should scan all the available ports. Actually, I know that you can scan the top 100, but it's recommended to scan all the available ports. Let's go ahead and scan it. You can use this command to scan every single port available to see which ports are open. Then we can see which services are open and which services are closed. So then we can decide which we can exploit. Okay, and let me explain fast what this means actually. Yeah, so this is like what we will do. Like, for example, this stuff, this 5 things are actually very this is what SOC analyst does. He's going to check the Wireshark. You can check this, like, for example, DNS tunneling, unusual DNS query volume and size. Okay, that means you will use Wireshark to check what are the queries and volume size, right? DNS data exfiltration. Exfiltration means taking data outside of your network. If an attacker tries to send your data to unknown IPs, you can use this one as we discussed here in Wireshark. You can do statistics, conversation, and IPv4. You can see like the communication. You can see, you can go through a weird IP address here, like, and check the bytes, how much byte it is taking out actually. Or you can filter this by the highest, from the highest to lowest. Okay, and byte A to B, right? We have byte A to B, and no, actually, A to B. We can just put this the highest. This is the highest one. Okay, and you can check the address, like if it is suspicious or not. Lateral movement, internal traffic to multiple hosts. Okay, these are the things that you can look. Even when you scan, by the way, when you do any scan, Nmap scan or anything, it could trigger like an IDS or firewall. They could like sense this, and if a company has a good SOC team, like, they will be able to know that someone is scanning their network, and they're going to do something about it, right? So all these things just we'll talk about it in details in the coming sessions. And network analysis technique, statics, conversation, flows between hosts, we talked about this. High volume to unusual ports, encrypted traffic to residential, many SYNAC, capture 100 packets of network and identify all protocol present in this. Daily challenge approach, step by step. Open Wireshark network, start capturing. Actually, we should do this stuff, but this is HTTPS.
we need to, this is very important actually, TLS and SSL handshake, HTTPS security at packet level. Okay, we've talked about HTTP. This is HTTPS. This is more secure because it uses certificate. Okay, how it uses the protocol called TLS 1.3 handshake. It has 5 packets: client hello, supported cipher key share, server hello, selected cipher certificate, server X, server key exchange, session key derivative, change cipher key, switch to encrypted tunnel between all application data encrypted, cannot see HTTP header or cookies, cannot extract credentials. Remember before when we were using HTTP, we were able to see the username and password in plain text. However, if we use HTTPS, it's going to use TLS 1.3 handshake, which is going to secure the packets, make it encrypted so you cannot see it, right? These are the common ports and services: 22 SH, SSH, 53 DNS, yeah, 80 HTTP, POP3, 110 IMAP, 143. These are actually email protocols: LDAP 389, HTTPS 443, SMB 445, 3389 is RTP, 3306 MySQL, Postgres 5432, and this is it. And this we've talked about it. And network reconnaissance indicators: attack signatures in Wireshark. Many send packets without acknowledgement. SYN flood attack. Okay. Port scanning, sequential connection to different ports. Multiple ARP replies for same IP. Okay, ARP spoofing. DNS poisoning, unexpected DNS response, man-in-the-middle attack. So let's yeah, we can extract file. We've talked about this actually, and we can use file, export object, timestamp, and find packet. So now let's go to Kali. Okay, we were able to identify like few ports here, and I want to do something actually to show you how it works. Like, I'm going to disable this one. Okay, I'm going to open new file, close, and don't save. So I'm going to go to VMnet 2. This is where the Kali and Windows are actually connected. I'm going to start the traffic. Okay, and I'm going to try to do something here. I'm going to try to ping, just so I can see ping 192.168. No, actually 10.0.0.21. Yeah, as you can see, it's seeing the traffic, right? Yeah, we can see that it's sending an echo and sequence here. Yeah, it's sending an echo request here. Okay, so it's seeing the traffic. Okay, so I want to do something here. I want to do nmap v. Okay, so it will check to see what traffics we're going to get. Let's use destination. There is a way to do this actually. Apply as filter selected. Yeah, so it doesn't have to be ICMP. You can just put apply as filter. Let's just apply as filter this one. Let's type 10.0.0.0. No, IP address. Let's just mention here 10.0.0.0.21. Exclude ping, not you don't really need ping, but so I just want to see exactly what's going to happen when we scan the ports. Okay, I'm going to scan all the ports. I want to see how it looks like in yeah, we want to see how it looks like in Wireshark. Let me just pause the video. Okay, the scan is actually completed, so let's just stop the capture and let's go through what happened, what just happened. Okay, so we scanned all the ports. Okay, so we can go like here. Let's go ahead and do the TCP as filter. Yeah, we're going to filter the TCP traffic here. Okay, and then you can see now, see it's going to check all the protocols, all the ports here. TCP flag sync, so it's going to go through each protocol here. Let's start with this IP, for example. We're going to use this this IP for now. Okay, so this IP 61945. Okay, first it's going to send to that, and then you can see that all the IPs, all the ports that it's scanning, you can see it here. You can see this huge number of ports that was scanned by the Nmap. Okay, like a SOC analyst would be able to identify this using even conversation. Yeah, conversation here, for example. We have IP address, yeah, and the packets, like how huge the packet is, and we can also do it using not the graph, actually, not the graph, I mean the endpoint, the graph, and there is one more, protocol hierarchy. Yeah, so let's see. There's TCP IP, and the bytes 40%, and not from here actually. Yeah, and we can see the endpoints. Yeah, so that's the whole point. This is like, you see this all sync, a lot of SYN packets, right? No acknowledgement. This is what it means, like when you scan, like it's just sending a SYN packet but no acknowledgement. That means it's syncing, it's just checking, because all the ports are closed. Actually, if it was open, it's going to send acknowledgement. Let me see what are open. Actually, 135. Try to search 135 here. If we type port 135, you're going to see acknowledgement 135.540. So let's see 135 TCP port, TCP dot port 135. Yeah, so 135, you see this, there is SYN-ACK, and there is a, yeah, because it's actually on, it's open, so you can see that there is a SYN acknowledgement. This is the first bucket, I think. Here you see the SYN packet, and here the SYN ACK, and here the set, and here the SYN ACK. Yeah, so basically that's it. That's about it. So we just covered a lot of topic in 1.5 hours. Okay, so in the next session we're going to start with reconnaissance and real world usage scanning. We're going to start ethical hacking. As I said, before moving on to ethical hacking, okay, you have to know 3 things: Linux, which we covered in our previous session, okay, and Windows internal, also we covered it in our previous session, and networking, we covered it here, okay. But also I advise you to go through my previous courses like CCNA here. You don't have to go through it all, just learn this first video, second video, and third video. At least it's the minimum you can learn. And you can also learn this one to know about wireless and the TCP relay and other things, okay. But this 3 you have to learn it. And also don't forget this Active Directory course I have here. Learning this is very useful for you as well, okay. And we're going to go through it, but you have to learn it for the HCP and DNS, so you understand how it works. And that's about it, okay. And in the next session we're going to go through reconnaissance. This is going to be our next session. We're going to deep dive on reconnaissance. So that's about it, this one. But before that we have to actually talk about pre-engagement scoping, okay. So I'm going to talk a little bit about it in the next session, okay. Then we'll start reconnaissance. Thank you for watching, and see you on the next video. Don't forget to like, subscribe, and comment.